We wish to graph the function y equals 0.00226t squared minus 4.3t plus 92. As before, we begin by finding the zeros, and in the process we're going to also find the vertex. So we plug a equals 0.00226, b equals negative 4.3, c equals 92 into the quadratic formula. A little bit sloppy here. I didn't put the negative in front of my 4.3 because I know the square is going to take care of it. And we simplify, being careful to divide both terms by the denominator, because remember that division is the same as multiplication by a reciprocal. Therefore we have a distributive property over plus or minus. Of course minus is just the same as plus. It's addition of a negative. And we circled in green the terms that are going to give us the coordinates of the vertex. And then we have plus or minus 930, which is going to give us the location of the zeros. And we think of this information as telling us that the vertex is at t equals 951, and that the zeros are 930 units to the right or the left of 951. Now, I've exaggerated the distance of this zero from the y-axis. On a scale where this is really 1800 and something, 951 minus 930 is 21. 21 is going to be very, very close to the y-axis. And I wanted to be sure that the position of that zero was clearly labeled. So we don't have a very accurate depiction of this zero. Once more, we're going to be able to find the location of the vertex on this axis of symmetry. We don't know how high or low it's going to be, but we're going to be able to find it by plugging 951 back into the function. I'll make one more note. The axis of symmetry is halfway between the zeros, and you might well ask what happens if we have a negative under the square root, because then we're not going to have a real number here. Well, that tells us that we don't have zeros. You might ask, where's the axis of symmetry then? Well, it's still at negative b over 2a. It's halfway between where the zeros would be if there were zeros.